Hey everyone, welcome to part 2 of right triangle trigonometry. In our last lesson, we learned how to solve for missing sides using right triangle trigonometry. And in today's lesson, we're going to learn how to solve for missing angles. So the first thing I would like you to do is go ahead and pause this video and do these first slide, the 3 problems in the first slide to warm up from things that we already know. So pause the video right now, try the 3 problems, come back and unpause it when done. All right, hopefully you had a chance to give these 3 problems your best shot. Here are the answers you should have came up with. Again, you can pause the video at this point for as long as you need to check your answers. And when you're ready, unpause it, and we'll move on with today's lesson. So in this lesson, like I said, we're going to learn how to find missing angles in right triangles. So let's start with this problem here. It says, what equation would we set up to solve for x? Let's use the trig that we know, and we're going to set up an equation to solve for x. So let's see. We see x up here. That's the angle we're going to look at. Never look at the right angle, right? We're going to look at this angle up here, and we're going to look at 6, and we're going to look at 13. With x, this would be the opposite leg. This would be the adjacent leg. This would be the hypotenuse. So we're using the adjacent leg and the hypotenuse. So that tells me we're going to use CAH, or we're going to use cosine. So my equation is going to be cosine. Every time we write a trig function down, the next thing we write down is an angle. We don't know the angle. It's x, so we're going to write down x. Equals, and then cosine is adjacent over hypotenuse, so that would be 6 over 13. Okay, as of right now, we don't know how to solve this. We'll come back to this in a second. Let's go to the next slide. Here's 3 equations you should know how to solve. To do the first one, where x is adding to 5, I would subtract 5 from both sides. To the second one, where x is multiplying 2, I would divide 2. And to the last one, where x is being squared, I would square root both sides. Why do we do that? Adding and subtracting, multiplying, dividing, squaring, and square rooting, those are called inverse operations. Sine, cosine, tangent, those are just operations. Okay? So for example, sine. Sine is an operation. We need an inverse operation to get rid of it. That is called sine inverse, and we write it like this: sine to the negative first power. It's not sine to the negative first power. It looks like that, but it's just sine inverse. The inverse of cosine is cosine inverse. The inverse of tangent is tangent inverse. All right, so let's go back to this previous problem here. So we see cosine of x equals 6 over 13. All right, I'm going to go ahead and just copy this down. So how do we get rid of that cosine? Here's what we're going to do. We're going to take the cosine inverse of this side and the cosine inverse of this side. And the left side, the cosine inverse and the cosine cancel each other out. So we're just left with x. And the right side, we're left with this. And that is actually what we're going to type into our calculator. So if you haven't already, I suggest you get your scientific calculator out right now. If you don't have a scientific calculator, you can use Calculate 84, or you can just, in Google, type scientific calculator. But hopefully you have a calculator app that has those 3 buttons on there. Okay, and then let's go ahead and split screen this. So quick check, hit the mode button to make sure that you are in degree mode. See how degree is highlighted? Now we're literally going to type this in exactly as we see it. Cosine inverse, how do we get cosine inverse? So you're going to hit second and then cosine. And what you go on your screen is cosine inverse. 6 divided by 13, close your parentheses. and hit enter. And we get our answer of 62.51. And angles are always measured in degrees in this unit, so 62.51 degrees. To summarize this, anytime you are looking for an angle using trigonometry, you are going to use one of the inverses: sine inverse, tangent inverse, or cosine inverse. So let's go to our next slide here. 2 problems for us to try. Let's take a look at 1a. So you see x. This is the adjacent leg here. This is the opposite leg here. This is the hypotenuse here. So we are using opposite and hypotenuse. So I know this is sine. So it's going to be sine of our angle equals opposite over hypotenuse. Now to solve this, we take the sine inverse of both sides. We get x equals sine inverse of 5 over 7. And that's what we type into our calculator. So in our calculator, we're going to get second sine, and the sign, the negative first should pop up, 5 over 7. And our answer here is 45.58 degrees. Letter B. So here we see the adjacent leg and the opposite leg, and the hypotenuse is blank. So since we're using O and A, this is going to be tangent, TOA. So tangent of our angle equals opposite over adjacent. Because we're looking for an angle, we're going to use inverse. So x equals tangent inverse 11 over 13. That's what we'll type into our calculator. Second tangent, 11 over 13. And we get 40.24 degrees. I hope that you are following along in your calculator out there so that you know how to use your calculator for this. You know how to type this in a calculator. Very important that you can do this on your own. All right, we're going to look at 2 more. At this point, if you're feeling confident, you want to try to pause the video here and try these, you're welcome to. If not, just continue on and let them play. So here we have the adjacent leg and the hypotenuse. So that is A and H. We're going to use cosine for this one. Cosine of x equals the adjacent leg over the hypotenuse. Because we're looking for an angle, we use inverse. So x equals cosine inverse 6 over 13. So in our calculator, second cosine, 6 over 13. And we get an angle of 62.51 degrees. One more before we look at some word problems. So letter D, I'm looking at the opposite leg and the hypotenuse. That's going to be sine. So sine of x equals opposite leg over hypotenuse. Take the inverse of both sides. We get x equals sine inverse 4 over 10. That's what goes into our calculator. And we get 23.58 degrees. All right, so let's take a look at a couple word problems here. Word problems the same as before. Basically, just on your own to draw your own triangle. And once you do that, it's the same as what we've been doing all day today. San Francisco, California is famous for its steep streets. The steepness of a road is often expressed as a percent grade. Filbert Street, the steepest street in San Francisco, has a 31.5% grade. It means the road rises 31.5 feet over a horizontal distance of 100. Find the angle created by the street and the horizontal line that represents sea level. All right, so we have a street that's slowly rising. And then we have a horizontal line that represents sea level. And of course, if we connect those, we will get a right triangle. Or at least something that's supposed to resemble a right triangle. Let's try this again. There we go. So the road rises 31.5 feet over a horizontal distance of 100 feet. And we want to know the angle created by the street and the horizontal line. Here's the street. Here's the horizontal line. The angle we're looking for is right there. So this is opposite and adjacent, which is TOA. So we're going to go tangent of x equals 31.5 over 100. And because we're looking for an angle, we're going to use inverse. So x equals tangent inverse 31.5 over 100. So on our calculator, second tangent inverse equals 31.5 over 100. And our angle will equal 17.48 degrees. Example 2, a 6-meter long ladder leans against a building. The ladder reaches 4 meters up the building. What angle does the ladder make with the ground? All right, so we have some ground here. That should be straight. We have a building on that ground. And we have a ladder reaching up that building. Of course, making a right triangle for it. The ladder is 6 meters long. The ladder reaches 4 meters up the building. What angle does the ladder make with the ground? So here we're looking at opposite and hypotenuse. That's going to be sine of x equals opposite over hypotenuse. So using inverse, we have x equals sine inverse 4 over 6. And that's what goes into our calculator, sine inverse of 4 over 6. And the angle the ladder makes with the ground is 41.81 degrees. All right, one more word problem. A restaurant needs to build a wheelchair ramp for its customers. The angle created by the ramp and the ground is 5 degrees. If the vertical distance from the sidewalk to the front door is 2 feet, how long will the ramp be? All right, so this is actually not one from today's lesson. This is actually one from yesterday's lesson, our previous lesson, because it tells us the angle. It says the angle is 5 degrees for the ramp. The vertical distance is 2 feet. So vertical would be here, that's 2 feet. And this is how long will the ramp be? So the question is this the ramp and is this the ramp? And hopefully you know that ramps are not flat. So we're looking at this up here. So that's going to be our variable. You can call it whatever you want. We'll call it x here. So looking at the angle, it's 5. This is going to be opposite leg. This is going to be hypotenuse. So we're going to use sine again. Sine of the angle equals opposite over hypotenuse. Now we're not using inverse because we're not looking for an angle. This is what we learned in our last lesson. When the x is in the denominator like this, we're going to end up dividing. So x equals 2 over sine 5. That's what we'll type into our calculator. 2 divided by sine 5. No inverse necessary here. And our answer is 22.95. And the unit would be feet. At this point, I would recommend again that you pause this video. On the next slide, there are 3 practice problems. You should pause this video, try your best, and come back and check your answers when you complete. And as promised, here are the answers to the last 3 problems. And that will do it for this lesson today. Feel free to go back and watch any parts that you might have had trouble with. Otherwise, hopefully we'll see you tomorrow.